And these examples are going to be run in a terminal. And so that is either in a terminal inside ThinLink or in the terminal that was used for regular SSH access. Just need to start. Well, this. Failed attempt to find the terminal. It will normally ask for a password as well, but it doesn't for me because I'm already on the SBC20 domain. Okay, so there will be a number of different examples here for you to try. There are some serial ones, some MPI and GPUs, and there are some constraints to play with. And both for getting different CPUs and different GPUs. And any programs mentioned in the batch script needs to be compiled before you can run it. With the exception of those that runs Python and those the one that's called compile run, which compiles itself. So there will be some examples here. You need to compile all of them. Just load FOSS 2023B. We'll see if I still have it loaded. I don't. And then if you want to run these multi-part ones, you also need to compile this all the C programs. Otherwise, you only need to compile the ones that I showed earlier. For these test examples, I did, as I said before, I named them so they have the same name as the C program. So if I run this, I will name the output adding 2. GCC 2 minus 4. Like that. If you do that, then you don't need to make changes to the batch scripts, which I have in all cases named with .sh as suffix. So there should be a description in front of each of these exercises where it tells you what you need to do in order to run it. But there's a serial job, an MPI job, OpenMP batch job, multiple serial jobs from the same file. There are also job arrays. And when you do that, you can see how it creates one for each of the steps in the array. It shows how you can do multiple parallel jobs sequentially. And again, it tells you here which C programs you need to compile in order to run it. Then there are multiple parallel jobs simultaneously. The difference between these are that if it's sequentially, they run one at a time, and you just need to ask for enough cores that the one that needs most cores has enough. And you don't need to put anything for it to wait because it does it one at a time. And of course, you need enough time that all jobs complete. Simultaneously is a different matter. Here you run them all at the same time, which means you need enough cores that all of them can run at the same time. and you also put an ampersand at the end so that they all start at the same time, and you do wait, because if you don't do wait, it will end the job the moment the first of these is finished, and you don't want that. You want it to wait until all of them has run. You can compile and run stuff in the batch job. You probably rarely want to do this. This is just an example. Another example shows how you get errors and outputs in separate files. And I have an example here that talks about dependencies. And there is also a small script that takes the job ID from the first job and uses it as prerequisite. It's also here. Then CUDA and GPU programs. How to ask for a specific GPU, V100, A100, A40, and such different ones here. There are a couple examples with that here, but you can make changes yourself if you want to. So, and you can also, if you want to go ahead and start Jupyter Lab, it can be done as a batch job, or you can do it on Open On Demand. So let's see how the time is. We are over time, but I think you need some time to try and run some of this. So Pedro, 20 minutes or something, then
It's fine from my
yeah,
side.
yeah.
Just let me know what time I would start.
It's 13:52, so let's say 12 maybe. 14:15.
Okay,
Let's do 14,
15.
14:15. Yeah,
Okay.
just do exercises until then. Try and run as many of these as you want to, just so you get a feel for how it behaves. And try and do the SQ minus minus me and the S control show job. This job that is called, let's see, these two go together. To this one generates a matrix or two matrices, and this does the multiplication, matrix multiplication. I just need to figure out which one it was that are doing the job. It's this one. These two here. So those two are run as dependencies. So this one has to run and finish before this one can start. And they are long. And this one is also a long program to run, especially if you allow it to run with the settings that they had originally in this one here. If you let the matrices be this big, because then it will run long enough that you can do the job minus usage and the job idea on it, and then get a URL and see how it develops in a browser. Okay, but play around with it and come back at 14:15 for some application examples.